Welcome. This is another one of the webinar done by IHE, Integrating the Healthcare Enterprise, on various topics that make interoperability and exchange of health information in healthcare better, easier, and more efficient. This specific presentation is on a new option that has been introduced for the document sharing infrastructure and other patient identification services, and it's called the Asynchronous AS4 Web Service option. I will give you a little bit more context. My name is Charles Parisot. I'm working for GE Healthcare. I'm a member of the ITI, IT Infrastructure Technical Committee, who developed this option, and I was one of the editors of the supplement. I'm also a board member of IHE International. So let's dive into our topic. Why has this asynchronous AS4 web service caught the interest of IHE? Generally, IHE profiles are performed and using synchronous web services, which is the requester of a service is waiting for the response that this service has been performed. Here we're talking of asynchronicity, where we disconnect the request and the response and do not create any wait time except at the application level. And the experience has shown that when we have large-scale infrastructure that are at the level of multiple communities that are interconnecting gateways serving regions or hospital systems, this creates a large system with a lot of transaction where the asynchronicity is beneficial and create a more efficient handling of latency and scale. This has led IHE to consider this asynchronous web service with AS4 and introduce it. We have a classical web service addressing base option, but we felt that AS4 that relies on the OSS AS4 work and EBMS 3.0 was a stack and a style of web services in the asynchronous world that was gaining momentum and receiving a fair amount of attention, especially due to its robustness and its ability to scale to very large infrastructure. Speaking of rather classical SOAP-based web services, where WS security is widely used to provide the necessary protection, we bring with AS4 both the pushing of a request and the push of the response, but also a pull mode where the receiver can actually request for messages and pull them, which we will see has a number of advantages in an environment where they are proxy and you try to never push data inside a area that has been secured. AS4 has also some optional payload compression that brings some efficiency. The robustness of the non-repudiation of origin, we know who is precisely sending. This exists also in the current option, but this is a little more robust, as well as the reception awareness. If the message doesn't go through, there is a possibility to resend the message, thus allowing gateways that are saturated to be compensated with that resending of transaction by the sender. We have a robust stack that is adopted outside of healthcare and which is also a benefit. So what IHE has done with this is to introduce a new supplement. This has been very recently released in August 2018, and we have this new Asynchronous Web Service as a new option. And it's an option that we have put on a specific number of profiles that are typically used in cross-community traffic. We see the two classical profile, XCA, cross-community access, where we move documents between gateways, where within the community, either an XDS, cross-enterprise document sharing type architecture is being used, or some other non-IHE deployment has been done. XCPD, that works along XCA to resolve the patient identification and the patient discovery handshake, so that query can always be performed against a correctly identified patient. This new option also applies to XDR for the simple push point-to-point of a document, and the XCDR where the push is not within a community but through gateways across communities. And this option is explicit where previously the other option could be used, but the web service addressing base web service was not explicitly made as an option. We wanted a little more rigor, a little more clarity for people that are procuring and testing a product. We have made sure that this asynchronous web service is an option so that we don't introduce any backward compatibility issue with the install base that is using either synchronous, that remain the requirement, and that may be using the current web service addressing base asynchronous and want to add or use instead the AS4 asynchronous web service as proposed in this new option. So having organized in your mind the general structure for this option and the profile in which it is now available, what we have introduced can be summarized as a number of features. We have looked at the not the whole EBMS 3.0, but specifically the AS4, which is a subset of EBMS, a conformance profile. And among the various conformance profile of AS4, we have selected the ones that are specific and correspond to the type of flow of information we have to deal with the EB handler and the light client. Security, classical web service security, XML signature, XML encryption, but we're not going in too many details because we know that different programs have a different deployment, have different algorithm and different policy, cipher and so forth to satisfy. Therefore, we're not overly prescriptive there. The reliable messaging is native into S4, as well as the error handling and the receipt handling, so nothing to spend too much time on there. The concept that is new and introduced by S4 is the MEP, the message exchange pattern. And message exchange patterns are a way to define between communicating AS4 base system how the transaction will follow and flow in terms of request-response pattern. We are using the two-way MEP, which is push and push or push and pull. And in that MEP, we are providing two basic modes so that we performed the classical and what we think are the main requirements, both in push and pull and push. So that flexibility is something new and will be very efficient when it comes to traversing in a secure way proxy or gateways that are protecting the communities that are being queried and from which information is being requested. If I go a little bit into more detail, you have this slide that shows the main point, which is between those two system or community that are communicating. The requester in AS4 and the provider are receiving the request message and the AS4 receipt that creates an exchange, a push if you want, in AS4 mode. And when the response is to be handled, that comes later on a completely asynchronous response message that has its own receipt. And you see that the communication system submit, deliver, and submit, those dotted lines are more interfaces within the communicating communities. And this is what you have shown here is a push and push message exchange pattern. Likewise, we can do a push and pull, and you see that the request message and the AS4 receipt are handled exactly the same way, but you now have this transaction number 7, which is having sent a request message. The left side application issues a pull request, and if there is a message, receive the message and then acknowledge the message with an AS4 receipt. So this is how the pull works, so that it is the receiver of the response that trigger the sending of that response message. It remains queued on the provider AS4 message handler. So in terms of structure and packaging, we'll go through that a little quickly because we're getting rather deep, and this is well explained into the supplement. We've made sure that we have as much consistency as possible between the two asynchronous mode and even the synchronous one, and use the freedom that AS4 leaves to make sure that the SOAP 1.2 body is used in a similar way as it is currently in the synchronous stack. We have allowed, as AS4 does, the use of MIME to put in a set of attachment the payload, the documents, if you want, if you are submitting documents or retrieving documents, and this is handled in the SOAP with attachment, which is the mode of handling attachment, which is defined by AS4. So no XOP, no XDOM as it is defined in the synchronous mode. Some people like this better, other people don't like it as well. So, but anyway, this is the way AS4 is defined. Now, we have a little technical problem, is if we put the documents in the attachment to the SOAP body, then we need to link the XML structure that speak to the specifics of those documents in the SOAP body and link them to the correct document in the attachment. And what we have done is we've done a dual mechanism, which is clean on one sense, in the sense that it is consistent with what AS4 does for those type of things, using the payload info. That's a native AS4 approach. And we have left the current method used by XOP to link document with attachment, and we do this in order to facilitate the coexistence and the adoption by existing IHE product that support MDOM and XOP. So everything that I said here that may appear a little complex is shown here in a graphical sense. So if the message doesn't contain complex payload, it is a simple SOAP packaging that you see here, where you see that the SOAP envelope contains all of the header information, and the SOAP body contains whatever is necessary for the XML of the document sharing that we are used to with EBRS. If we now have attachment, the message brings the MIME envelope and the MIME parts, where the first part contains the SOAP header and the SOAP body, and the other part contains the various documents, eventually compressed, signed, and encrypted if needed. And the linkage, as I explained, is done in a dual mode. This is a little bit of a simplified header, but you see on the left side a mechanism that uses the EB part info, and that basically say, hey, this is document 1, and you have actually the CID of the document in the attachment, and you have another CID for the document number 2. And we keep the existing one, which is using the extrinsic object document identification and a link in the XOP include that you see at the bottom of the picture for document 1 and document 2. So those two mechanisms do the same thing. The left side is more backward compatible with the existing right side, and the left side is what we have today in the MDOM XOP structure. So having brought that flexibility and that continuity, we have a pretty complete specification. We have, of course, defined a number of other EB attributes that are necessary, like EB service, EB action. I'm not going to go into those details, but they allow and they have a very specific profiling that makes sure that the profile, the IHE profile, can be implemented. That doesn't leave anything for interpretation. And the final slide will show us that the trial implementation process for this supplement has started, and we will see and hope to see many implementation at the Connectathon in 2019 in January in North America, and in April 2019 in Europe. We have a status trial implementation because in IHE we will wait until we have the result of those Connectathon that will tell us if indeed we have interoperability, if we have good readability of the specification, and any correction, clarification will be applied before the profile becomes final text, sometimes in 2019 or late 2000 or later in 2020. If you want to access this supplement, it's on the IHE website, and you have the link on the second bullet of this slide. I want to thank you very much. Hope you found this new supplement enriching the use of web services in these document sharing IHE profile, and we will see you at the Connectathon having implemented and tested this new asynchronous option. Thank you very much for your attention, and do not hesitate to use the IHE email addresses and comments on the wiki if you have any question about this new supplement. Thank you.